All Academy. Always with you.
Hello my dear students, welcome to this online video lecture on basic thermodynamics. So in the previous video, we have discussed the basic definition of thermodynamics. Then we have studied the different approach, that is microscopic and macroscopic approach of thermodynamics. Then also we have studied what is thermodynamic system. Then again in that we are having open system, that is and closed system and isolated system. We have discussed these all important concepts in the previous session. So today in this video we are going to discuss the different thermodynamic properties, then the type of thermodynamic properties. Then along with that we will continue what is thermodynamic state, how we define the thermodynamic state, then the thermodynamic process. Then we'll see the thermodynamic equilibrium. And again, so what are the condition to satisfy by the thermodynamic system to have achieve a thermodynamic equilibrium. So these all concepts we're going to study in today's session. So without wasting much time, let us begin with the
Let us start this session with the thermodynamic properties. So what are these thermodynamic properties? Before that, let us know what is this property. So the variables which determines the state or exact condition of a substance or a system are called properties. So the properties which are the variables or the measurable variables which describes the exact condition of a system are called property. So in thermodynamics, the thermodynamic measurable properties which describes the thermodynamic system are called the thermodynamic properties. Means the properties like pressure, temperature, volume, specific volume, internal energy, enthalpy, entropy, etc. So these are the properties which helps us to describe the condition of a thermodynamic system. Such a properties are called thermodynamic properties. And these thermodynamic properties are classified or grouped into three types. So these thermodynamic properties are classified into three types. So one is extensive property, and another one is a intensive property, and the third one is a specific property. So the whatever thermodynamic properties used to describe the thermodynamic system are classified into three categories. One is extensive property, intensive properties, and specific properties. So let us discuss in details about these properties. So what is this extensive properties? The properties of a system which are dependent on the mass are called extensive properties. Means the properties which are dependent on a mass are called extensive properties. The examples: volume, mass, enthalpy, entropy, energy. So these all properties are dependent on a mass of a system, and thus these properties are called extensive properties. The next type of properties are intensive properties. The properties of a system which are independent of mass. So the properties of a system which are independent of mass are called intensive property. And the example for the intensive properties are temperature, pressure, density. Means these values are not dependent on the mass of a system. So the properties which are independent of mass are called intensive properties. Now the specific property can be defined as the properties of a system which are described per unit mass. So the properties which are described per unit mass are called specific properties. The example: specific volume, specific enthalpy, specific energy. In other words, I can say that these are the properties derived from the extensive properties, and the specific properties are obtained by dividing with the mass for the extensive properties. So the properties are described per unit mass. You can see that volume, enthalpy, energy. So if I divide it by mass, so then these extensive properties will become specific properties. So now, so what are the three types of properties, thermodynamic properties? These are extensive property, intensive property, and specific properties.
So this is all about the thermodynamic properties and the types of thermodynamic properties, means the classification of thermodynamic properties. So let us go in details with the definition of these properties like pressure, volume, temperature. So let us go in details. Let us see the definition of these properties in details.
So one is pressure. First one is a pressure. So pressure may be defined as a normal force per unit area, and generally it is expressed in a pascals or bar. Okay, so that is a pressure. So pressure is defined as normal force per unit area. The next definition is temperature. A temperature is a thermodynamic property which determines the degree of hotness or coldness of a body, and it is expressed in Kelvin or in degree Celsius. The next one is a volume. The space occupied by the substance is called volume, and it is expressed in meter cube. The next one is a specific volume. It is defined as the volume per unit mass. It is a specific volume of a substance. It is a volume per unit mass. So it is known as specific volume, and it is expressed in meter cube per kg. The next one is a density. As you all know that, so density of any substance is a mass per unit volume, and it is expressed in kg per meter cube. So density can be defined as the ratio of mass per unit volume. The next one is a energy. So energy can be defined as a capacity to do some work, and all form of energies are mainly classified, means whatever energies are there, these are classified into stored energy and a transient energy. So what are these stored energy? Stored energy is the energy possessed by the system within the system boundary. So whatever energy present within the system boundary, it is known as stored energy. Example, kinetic energy, potential energy, internal energy. So these are called as stored energy. Now what is this transient energy? It is the energy possessed by the system which is capable of crossing the system boundary, means the energy which can interact or which can move across the system boundaries. Such energies are called transient energy. And some of the example for transient energy are the heat energy, work energy. So these are the transient energies. So next definition is heat. So as you all know that heat is defined as a energy transferred across the system boundary, as we have previously discussed. So this is a transient form of an energy. So heat is a transient form of energy which can crosses the system boundary, and due to the temperature difference, that is very important. The energy transfer, the heat transfer takes place only due to the temperature difference between the system and the surrounding, and generally it is expressed in a Newton meter or joules. Now heat added to the system, so that is very important. Now heat added to the system is considered as a positive, whereas heat rejected from the system is considered as a negative. Okay, it is denoted by positive sign and it is denoted by negative sign. The next important, very important definition is work. So work is defined as a energy transferred without transfer of mass across the system boundary because of intensive property difference other than the temperature that exists between the system and the surrounding. It is nothing but the work interaction between the system and the surrounding, or the energy interaction between system and surrounding, and it is also expressed in Newton meter or joules. Now work done by the system, means work done by the system is considered as a positive sign, whereas the work done on the system is considered as a negative. So I have clearly, by this figure you can clearly understand work done by the system is positive and work done on the system is a negative. So next, one more important definition is a enthalpy. So the enthalpy is nothing but the total heat and the heat content. It is a nothing but the total heat and the heat content. So enthalpy can be expressed as a sum of internal energy and the product of pressure and volume. It is nothing but a product of, so it is a sum of product energy and the product of pressure and volume. And this enthalpy can be denoted by the letter H. So we know that internal energy can be denoted by U, and product of P and V, that is pressure and volume. So H can be mathematically it is expressed as H will be equals to U plus PV. Now the absolute value of an enthalpy cannot be measured, but only the change in the enthalpy can be measured. because this energy, the internal energy is changing with respect to time, so it is quite difficult to measure that particular time. So the absolute value of an enthalpy is difficult to measure, but as a result we can measure only the change in the enthalpy. So the change in enthalpy can be denoted by delta H or dH, that is H2 minus H1. So that will be equals to internal change in the internal energy, that is U2 minus U1 plus PV2 minus PV1. So that is a change in the internal energy. So mathematically it is expressed as U2 minus U1 plus P into V2 minus V1. So this is a change in the internal energy or change in the enthalpy. Now the next definition is entropy. So what is this entropy? Entropy is represented by the small letter S. So the small increase of entropy, that is delta S of a substance, is defined as, so generally we say that entropy is a measure of randomness. Now here I am expressing the delta S. So the delta S is defined as the ratio of small addition of a heat, that is dq, small addition of a heat, that is dq, to absolute temperature T of the working substance at which the heat is supplied, and it is expressed in joule per kg per Kelvin. So mathematically it is expressed as ds will be equals to dq divided by dt, or dq will be equals to T into dc. So this is a mathematical expression of the small change in the delta S, that is increase in the entropy, that is delta S. So the delta S is a change in the entropy. So next we'll discuss about the thermodynamic state. That is very important, that so whenever if I want to define any system, so its state must be defined before we analyze or we proceed with the analysis. So similarly, what is this state? A state is a condition of a system at any instant or at an instant of a time. Okay, so state is the exact condition of a system at any instant of time as described or by using some measured or measurable properties. So the state is a condition which is defined at any instant or instant of time as described or measured by some of its properties. In other words, I can say that the state is a exact and unique condition of a system. Okay, is called state. It is a exact and unique condition of a system is called state, because when the thermodynamic system, when it some properties if they get changed, the even this state is completely different. So this can be explained by using some example. So in figure what you are observing, the cylinder, the piston cylinder arrangement contains some gas of mass 2 kg, temperature 20 degree and volume V1. So I can say that this is at condition 1. If any one variable among these properties, so as clearly mentioned, described by some using measurable properties. So as per the definition, it is measured by using its properties. If any properties among these, if they get changes, so then this cannot be said as a same condition. This cylinder or piston, this thermodynamic system cannot be a same condition. So as you can see in this figure, so here the volume of a gas is changed, so to 2.5. As you can see that, so there is a change in the volume you are observing. So even though there is other two parameters are kept constant, only one parameter is changed. So then these two conditions are not same. So it is a unique condition. So whenever if there is a change in the properties, so the thermodynamic system becomes different from the initial condition. Now let us discuss the thermodynamic process. So when one or more of the thermodynamic properties of the system changes, so we say that there is a change of state of a system. So this change of state of a system is referred as thermodynamic process. So let us take an example of a piston cylinder. So the initial position of a piston is considered as 1. When piston travel to some specified position, that is consider that position as a 2. Now the whatever path occupied by the piston or the direction through which the piston moves is considered as a thermodynamic process. That will be a process. But generally when system, in other words I can say that when the system changes its state from one equilibrium condition to another equilibrium condition, and the path of successive state through which the system has passed is known as the thermodynamic process. So if there is a change in one thermodynamic system to one thermodynamic equilibrium to another thermodynamic equilibrium, and whatever path it has been taken during this change of equilibrium condition, that change of path is known as the thermodynamic process. Now let us study the quasi-static process. So one more important concept, that is quasi-static process. A quasi-static process is a one in which the deviation from equilibrium is very small. So all the state through which the system passes during the process can be considered as a succession of equilibrium state. So whenever the process is carried out in such a rate that at every intermediate points the equilibrium condition can be described and fixed, then such a process are known as quasi-static process. Now this quasi-static process can be understood by using the simple experiment. So what you are observing in this animation, so that is a simple quasi-static process. So let us consider the piston cylinder arrangement at position, some fixed position without any loading. Whenever I start loading on that one, so this piston will take some different position for one load. Then again, if I increase the load, then it will changes its position. So as that, so there is a small change, means every increase in the loading or the weight, so there will be small changes in the piston position. So that change in the position is known in the process is known as a quasi-static process. And this quasi-static process can also known as reversible process, means I can reverse this complete process. So if I start removing the one by one load, so this piston can take its original position. So this quasi-static process is also a reversible process. Now during this quasi-static process, so it is as compared to other process, this is a slow condition, because at every instant I need to describe the condition of a thermodynamic system. Now during this process, if any one properties remains constant or kept constant, then the prefix ISO is used to describe such a process. For example, during this quasi-static process, if temperature is kept constant, then it is a isothermal process. Or if the pressure is kept constant, means it is a isobaric process. So that is a prefix used. If any one properties are kept constant during this process, then the prefix iso is used. Now let us study the reversible and irreversible process. What is this reversible process? A process is called reversible if it can be completely reversed and the system and surrounding can come back to its original place. Means if the whole process can be reversed and system and surrounding can attain their original position, then such a process are called reversible process. The best example for reversible process are reversible adiabatic process, where the system and where it will come back to its initial position. Now what is this irreversible process? If the process cannot be exactly reversed, then the system cannot come back to its initial position. Then such a process are called irreversible process. So means the process in which the system cannot be reversed or the process cannot be reversed, such a process are called irreversible process. And the best example for irreversible process is flow through pipes involving the friction. Means when it comes out, the pipe cannot be, means the water cannot be, it cannot recirculate unless and until I have used some external aid. So that is very important. So reversible process, the completely it can be reversed, but whereas in irreversible process I cannot reverse it completely or exactly. So here in this figure you can easily observe that the reversible process means at initial position at condition 1 it is there, it will take some process. So this is, and if it again come back to its original position, so then it is a reversible process. If the process cannot take back to its initial position, so then it is a irreversible process. So the next important topic is thermodynamic cycle. When a number of processes in a sequence bring the system back to its initial state, then the system is said to have undergone a thermodynamic cycle. Now in this figure you can see that Initially, there is 4 process which are taking in a sequence 1 to 2, 2 to 3, 3 to 4, and back to from 4 to 1. So these are the 4 cycles, and it bring back to initial position. If the after reaching a final process, if it come back to its original point or initial position, then I can say that the system is undergone a thermodynamic cycle. And one more very important is whenever the naming of these means the numbering for the thermodynamic process has to be taken from initial position, that is 1, 2, 3, 4, and again I have to give a last one, that is 4, as I have mentioned here. 1 has to be written. And one more very important thing to be noted in the thermodynamic cycle is there will be no change in the properties, means the change in the value of properties will be 0 for cyclic process, such as the change in pressure, change in volume will be 0 in thermodynamic cyclic process. So let us see what are the important questions. So the important questions on the topics which we have discussed today. So one is define thermodynamic property, then how these thermodynamic properties are classified, then differentiate between the intensive and extensive properties, define thermodynamic state, then what is thermodynamic process, then what is thermodynamic cycle. So these are the some important questions on the topics which we have discussed.
So hope dear students, the whatever topics, the whatever concepts, thermodynamic concepts discussed in today's sessions, you have understood all the concepts. Still, if you are not able to understand, or if you are having any confusion with any topics discussed in today's session, so you can comment it in a comment box, and we'll try to clarify your doubts.
Click on subscribe button and press the bell icon to get updates from All Academy.